Hello students, I am Dr. V. Sadhana, Assistant Professor of Physics, St.Joseph College of Arts and Science Autonomous, Cuddalore. In this video, we are going to discuss a small topic, probability current density, which leads to the equation of continuity from the subject Quantum Mechanics 1. When a particle moving in a system, the probability of finding that particle inside the system, since it is in the motion, it may be difficult to find out exact position of the particle and momentum of the particle at any instant. So at that time we can calculate the probability of the particle inside the system. So the probability current density may be interpreted as the particle probability amplitude. That is, the motion of particle is clearly be associated with the motion of wave function. So we can find the amplitude, probability amplitude of that particle, which leads to the idea of probability current density. Let P of R is the probability of finding the particle at a particular point in space. Then the probability of finding the particle in a region of space of a volume V, which is bounded by a surface A, is given by P is equal to integral V P of R d tau. Here d tau is a volume element, may be represented by dx dy dz. And using the wave function, it may be written as integral V psi star d tau. So the probability, to discuss about the flow of probability of the above relation, we must know the changes in the probability with time within that surface A. So for that, we have to differentiate that equation with respect to time. Now differentiating P with respect to t, it becomes d by dt of integral V psi star d tau. D by dt, when get into the integral, it becomes partial differentiation, that is dou by dou t. And here psi star is of the form duv. So duv, differentiating duv will give you u dv plus v du. So psi dou psi star by dou t plus dou psi by dou t into psi star into d tau. We know that the time dependence coordinate equation given by h psi is equal to E psi. So E, energy operator E is equal to I h cross dou by dou t. So I h cross dou psi by dou t is equal to minus h cross square by 2m del square psi plus V psi. Since h, the Hamiltonian in h is equal to minus h cross square by 2m plus V. Now taking the complex conjugate of the above equation, it becomes minus h cross square by 2m del square psi star. Psi becomes psi star complex conjugate plus V psi star is equal to I minus I h cross dou psi star by dou t. Now multiplying the equation 3 by psi star and 4 by psi star, and then we are going to subtract the equation 3 from 4. So first, multiplying 3 by psi star, it becomes minus h cross square by 2m del square psi into psi star plus V psi into psi star equal to I h cross dou psi by dou t into psi star. Let it be 3a. And multiplying psi in the equation 4, it becomes minus h cross square by 2m del square psi star into psi plus V psi star into psi equal to minus I h cross dou psi star by dou t into psi. Let it be 4a. Now subtract the equation 3a from 4a, we get minus h cross square by 2m psi del square psi star minus becomes plus, so plus h cross square by 2m psi star del square psi equal to minus IH cross psi dou psi star by dou t minus IH cross psi star dou psi by dou t. Or we can neglect the negative signs and rearranging the equation, taking the h cross square by 2m as a common term out, it becomes h cross square by 2m into psi star del square psi minus psi del square psi star. In the right hand side, IH cross is a common term. Now it becomes IH cross into psi dou psi star by dou t plus psi star dou psi by dou t, which is equal to minus h cross square by 2im. This I came from the right hand side, and so when it is in the denominator, it becomes I minus. So minus h cross square by 2im psi star del square psi minus psi del square psi star into d tau is equal to psi dou psi star by dou t plus psi star dou psi by dou t. Let it be equation number 5. Using the equation number 5, we can replace the value of psi dou psi star by dou t plus psi star dou psi by dou t in equation 2 as dp by dt is equal to minus h cross by 2im psi star del square psi minus psi del square psi star into d tau. But here we have to change the volume integral into a closed area, so that then only we can find the particle inside the system. When it will be a very closed, so it may be, volume may be converted into a surface integral. So it becomes one integral may be cancelled. So minus h cross by 2im integral A, after application of one integration, it becomes psi star del psi. Here del square becomes del psi minus psi del psi star. So here also del square becomes del psi into dA. Let S of R T, S of R comma T be probability current density. The changes in the probability are due to flow of probability current S. So this is the reasonable interpretation given for S of R comma T. Hence the changes in the probability is absolutely because of a flow of particles. So now it may resemble the hydrodynamics, equation of continuity in hydrodynamics. See, here we can write S of R comma T as h cross by 2im psi star del psi minus psi del psi star. Here, implementing the relation between the probability density and the probability current density, it becomes dP by dt is equal to minus integral S dA, which is given by minus di S. So it becomes dP by dt plus di S is equal to 0, which is analogous to the well-known equation of continuity in hydrodynamics. That is dou rho by dou T plus di J is equal to 0. Here rho is the fluid density and J is the current density. So this equation number 9 may be said to be equation of continuity. And this is the equation to find the probability current density of a particle inside a system. Thank you for listening. Thank you.